We are going to extend our knowledge of polynomials. Previously, we have looked at a regular horizontal line, a straight line, and a parabola. Now we're going to talk about what's it mean to make it a polynomial. A polynomial has continuous graphs. It's a smooth line. Doesn't have any jumps in it like this. It has rounded turns, no pointy turns like an absolute value graph. And that's basically what you go by. The leading coefficient test will tell you how a polynomial is going to end. For example, when your n is odd, which is talking about your degree, the highest exponent on x that you have. Okay, so when you have an odd degree, your leading coefficient is positive, the graph falls to the left and rises to the right. And if your degree is odd and your lead coefficient is negative, it's the opposite of that. It rises to the left and falls to the right. The way I remember it is odds are opposite. Odd degrees have opposite end behavior. Even degrees have the same end behavior. When the leading coefficient is positive, the graph will go up on both sides. When the leading coefficient is negative, the graph will go down on both sides. Some people need a way to remember this. This is one way, this pole, pay, null, and nil test. If your degree is odd, the sign of your leading coefficient is positive, it is going to start low, going down, and it ends high, going up. So that is where POLH is positive, odd, low, high. So on pay, you have positive, even, and it's high on both sides, meaning it goes up and up. When you have a negative, odd, NO, you are high on the left and low on the right. Up on the left, down on the right. When you are negative and even, you are low on both sides, down and down. So some people can remember these, some people can't. Like I said, I remember odd is opposite, and I just remember low to high. Unless it's negative, then it's high to low. But whatever works for you. When it says describe the end behavior, you are talking about what is it doing to the left and to the right. Okay, we have got a positive leading coefficient. We have got an odd degree. So positive leading coefficient, odd degree, odd. I know that they're going to be in opposite directions, down and up. So I'm going to say falls to the left, rises to the right. All right, the second example is negative and even, which means they're both going to be down. So I would say falls left and right. Finding the zeros of a polynomial. When you are finding zeros, these are the solutions or the roots of a polynomial. They make the polynomial equal to 0, hence the name 0. You can find these by graphing. I want you to be able to find them without graphing on your calculator. Therefore, factoring. So find what x values make this equation equal to 0. I'm going to factor. All these have an x in common, so I'm going to take that out. X squared minus 12x plus 36. And this looks like an easy factoring. X times x and x. What multiplies to 36 adds to negative 12. It's going to be negative 6 and negative 6. I take each of my factors and set them equal to 0. X equals 0, x minus 6 equals 0, x minus 6 equals 0. My solutions are 0 and 6. That is where my polynomial is going to cross or touch the x-axis at x equals 0 and 6. Okay, I'm going to factor this one again. They all at least have an x squared in common, and I'm going to hope I can take out a negative 1/4 out of everything. And let's actually write negative 1/4. Parentheses. First one's easy. That's going to be an x squared. Second one, 3/2 divided by negative 1/4 leaves me with a negative 6x. And negative 9/4 divided by negative 1/4 is 9. So positive 9. Factor what's left. I've got negative 1/4 x squared. This will be x and x, multiplies to 9, adds to negative 6, negative 3, negative 3. Set all of them equal to 0. This one, x equals 0, and these two make the same thing, x equals 3. One more to practice your factoring. Or this one you cannot factor. 5 terms, nothing in common. So we're going to have to rely on our calculator for this one. Okay, so I have put my polynomial into my y equals. I'm going to hit graph to see what this looks like. I can see that there are 3 zeros I need to find. I'm going to work on finding this furthest left one. Go to second, trace. You are looking for a 0, so you want the second option. I'm going to arrow over until I am to the left of that 0 and press enter. I'm going to go to the right until I'm to the right of it. Press enter, and one more time. So I'm going to list this 0 as negative 1.73. So after repeating the process, I found the one that I did on the video, and I found 2 more with the same process. So this is the last resort you can do when your polynomial does not factor.